Welcome. So I wanted to start out. This morning by taking everybody back a few years, or a few years in my life, which is actually 20 years, to 1998 and my first startup. But the story isn't really about working in a startup, because also in 1998, at the same time, I started dating the woman who is now my wife. And this is a story a little bit about her, but more importantly, about Christmas turkey. And so we'd been dating for about 3 months, let's say, and I had the opportunity for the first time to meet her parents. Everybody loves meeting the parents of the person they're dating, right? And so she invited me over for dinner, but she only gave her parents about 20 or 30 minutes of notice. And it was a couple days after Christmas, and so they were only planning on having leftover turkey. And when I arrived at the house, they were very apologetic about this. We're really sorry, all we have is turkey. And I thought, that's weird, I love turkey. I mean, Christmas leftovers is one of my favorite things. Why are they so upset about this? So we sit down, and we're eating dinner, or we're getting ready to eat dinner, right? And the food's being passed around the table. And Dana, that's my wife, so her father is sitting on my right, and he passes me some beans, and I take some beans, and he passes me some salad, I take some salad, and then the turkey comes around, and he passes it over me to Dana's sister, who's sitting on my left. And I thought, well, that's kind of weird, but I mean, I just met these people, right? I'm not going to be confrontational about it. Is this a rite of passage? Do you have to come for dinner 5 times before anyone will give you the turkey? Like what exactly is going on here? So we eat, I clear my plate of the salad and beans. I'm a little hungry still, I gotta say. And so everyone's kind of looking around. There's a weird, awkward silence. And people are looking at me because they can see that I'm eyeing the various forms of food at the table. And then finally, Dana's mom, she says, "Rob, can I get you anything else?" And now I'm put on the spot, right? So I said, can I, would it be, can I have some turkey? And everyone stops. And everyone turns and looks at Dana. And Dana looks at me and says, "I thought you were vegetarian." And the thing is, I was just broke, right? I was working at a startup. It was like friends and family funded. And I thought, because I was young and foolish, the way to win the heart of this woman that I was dating was to take her to all the finest restaurants in Toronto, where I was living at the time. But I couldn't afford it, so I would get the vegetarian dish because it was the cheapest. But what's craziest to me about this is that it was so obvious to her that I was a vegetarian that she never even asked. So this is the key point that I want to leave with you here today, which is that you need to own your own story, because this is happening every day around you. It's true in dating, it's true in life, it's true at work. If you're not clearly conveying to people what's happening and why things are happening, they're making up their own impressions in their mind, and they're deciding what the story is. And telling everybody else. I mean, she told her parents all this. She told all her friends I was vegetarian, and we had never, ever talked about it. Bringing this a little bit closer to home and closer to work, let's say. Before that startup, in my first job out of college, I worked in a multinational manufacturing facility. So it was a factory, and I was a process engineer, and I was responsible for the quality and effectiveness of the process as we delivered. Think Foxconn, we're building, electronic circuit boards, basically. And after my first year, I had a horrific annual review. I'm kind of proud of it, actually. I was going to say I'm not proud to say I'm super proud of it. And the feedback that I got from my manager was that she had been up on the factory floor over the course of the year and had heard from folks that worked up there that I was slowly disengaging. Over the course of that year, other engineers in the same role were spending more and more time on the factory floor solving real problems, and they were seeing less and less of me. And they to the point where it seemed like I was sending other people to the factory to work on my products for me. But the reality of the situation was I was down in my cubicle building an analytics pipeline that explained to all of these engineers what was wrong with their products so they could actually go to the factory floor and fix it. It was so obvious to me, the value that I was delivering, that I had never bothered to talk about it with my manager. I just talked to the other engineers, and we figured out this was the thing we had to do, and I spent all of my time doing it. So again, very, very important to be telling that story and talking about the value that we're delivering. So we're software engineers, right? Most of us, I'm assuming, are in software engineering management, something like it. How do we measure value? How do we measure the value that we're delivering as software engineers? We're not very good at it. I'll be honest with you. And I'll tell you, we haven't been very good at it for a very, very long time. In fact, I would say we've been bad at it for a very, very long time. I don't know if anybody remembers this little gem. Hopefully you can see it up there. But I downloaded this just for fun. It's a source line of code counter that is copyright through 2004, so I'm assuming we've given up on this. But I ran it across the project that I wrote to generate the charts for this talk. 576 lines of code, not a lot. But take a look at the numbers. Apparently, that should have taken me 2.8 months, and that would be a $15,000 value, where value is measured in what you pay software engineers. If you look to the left, you can see the average salary of a software developer. Clearly, there's some updates to this to be done. But what does that mean? It doesn't really mean anything. First of all, that was about 4 hours of work, not 2.8 months. So the calculation is clearly wrong. And how did I deliver so much value in 4 hours? Copy and paste, my friends. This is not important to me. This is not a sustainable, well-tested, well-developed, easy-to-maintain set of code. It's a bunch of stuff that I threw together to make some charts, and then I'm done with it, right? So how am I thinking about that value? Is that really what we should be thinking about? No. So as I said, we've given up on this, but we haven't found a good replacement. We've basically concluded that you're effective if you're very busy. But busy doing what? Busy digging through a labyrinth of tech debt trying to get something out the door? Busy fighting your flaky tests in your build environment trying to actually get the thing that you built out into production? Busy arguing over white space in your PRs? None of those things really feel valuable, right? So when we're cranking it out all hours of the night and chalking up all the Red Bull cans on our desk like, hey, I'm really crushing it, when you ship that thing finally at 4 a.m. and you're super proud, I think the question is, why wasn't I able to do it at 4 p.m.? Right? Like, why couldn't I have got this done in a normal amount of time and go home? Busy does not equal effective. This is a commutable equation. Busy does not equal effective. Busy just means busy. It just means I'm doing stuff. But what am I actually delivering? This is how I want to feel when I work. Partly because I got something done and now I can actually go skiing and do something fun that I want to do with my life. But also, more metaphorically, this weightless feeling of I'm not being dragged down by all the things around me that are slowing me down and keeping me from delivering what I really want to do. Because let's be honest, as engineers, do we want to do battle with our systems? No. We want to deliver value, right? We want to deliver things that our customers are excited about, that are building on the business, that are the interesting problems. I mean, even if it's not the sort of UI customer-facing stuff, we want to solve the interesting problems. And we're solving the kind of mundane problems. I mean, let's talk about flaky tests. Would you go off this ramp if it kind of works sometimes, but you never really knew? I don't think so, right? This is trust in your system and knowing that things are going to work effectively. That's what gets you this feeling of flight, we'll call it. So I'm the CTO of CircleCI. I think you figured that out from my cover slide. But one of the things that's really awesome about working at CircleCI is where we happen to sit. And what I mean by that, I mean, our offices are lovely, but where we sit in the developer pipeline. So we are software developers. I am a software developer, have been for a very long time. I run a team of software developers, and we think about software development for our own sake. We want to be good at what we do. But we also have the opportunity from 25,000 plus organizations to look at who else is out there and how they act and what they do. And this has given us an opportunity to really sit down and think about this problem. What does it mean to be effective? What does it mean to deliver value? And so I'm actually not a software engineer by training. I studied engineering physics, so I have a little science in my background. I think about this in sort of the terms of the scientific method, right? Let's figure out a hypothesis. Let's go test that hypothesis, and then let's draw some conclusions. Or more likely, find out we're wrong, start with a new hypothesis, and go through the process a few times. But we only have 40 minutes, so we'll streamline the process a little bit. So, with this information in front of us and this question of what can we learn, or what do we already know about what it means to be effective and about organizations that maybe use our platform, customers of ours, and how they're being effective, we went looking for some clues. And one of the interesting things that we discovered pretty early, just sitting down and not digging into any data or doing any real analysis, but just talking through what have we heard from customers. One of the things that I've heard, so I've been at CircleCI a little over 4 years, and one of the things that I hear consistently and have heard for 4 years is my build time is critical. If my build time crosses X threshold, then my engineers are wasting their time, they can't be productive, this is a massive waste of money. I will do anything to get my build time under X. But what's amazing about that is that X varies from about 3 minutes to 90 minutes. That says to me that we don't talk to each other very much. If I'm sitting in an organization thinking that like the pinnacle of success is if my build is under 90 minutes and the person doing the same thing next to me thinks it's 3 minutes, we're not having the right conversations. And honestly, is this our secret sauce? Is this, as an organization, is the thing that's differentiating us from our competitors our secret knowledge about how fast our build runs? Not really. I mean, we're building open source libraries and putting them out there that our competitors can use, and that doesn't hold us back, right? So this feels like, getting back to the point of hard problems, an opportunity for us to start talking more and sharing what we know so that we can go focus on the things that are really interesting to us as engineers. So, okay, build time seems important, but no one knows what it should be. Let's think about that. We'll park it for a second and start thinking about other things that we know about from where we're sitting. So let's talk about builds. We run a lot of them. We see a lot of them. And I don't know how many of you are CircleCI customers or use CI at all, but if you're like me, the green build is a little bit exciting. Like, this is progress, right? So what does it mean to be a green build? First of all, let's focus on master, right? If you're a GitHub user, you probably think of the primary, or if you're a Git user, I guess, you probably think of your primary or default branch as master. There might be another name for it. I'm going to call it master for the sake of this. Every other branch is a little bit of noise, right? It might just be safety commit. I had this on my laptop. I needed it to be somewhere else, so I committed it to GitHub. That doesn't really matter, right? But the master branch is precious. This is where all of the work is coming together and getting out through the pipeline and into production, or maybe just into your Docker registry or whatever the asset might be. And so every single time you get a green build, you're a hero. This is exciting. We're winning. We're making progress. Maybe we're defeating the empire. I don't know. That might be a little bit hard to go or far to go on a green build, but it's exciting, right? It's like a little boost of excitement and enthusiasm and energy that comes from this achievement, right? Ugh. What about red builds? Red builds are terrible. Think about master branch red builds, right? How does that even happen? You probably built on your branch, and then you merged it, and someone else built on their branch, and they merged it, and it failed. Now, like, in a lean culture, someone's yanking the andon cord, right? Stop everything. Let's go fix the build. How did we get into this situation? Flaky tests? Anybody have flaky tests? Anyone ever seen a flaky test? Maybe one or two? Yeah. As a software development community, I can tell you, again, from where I sit, we're actually pretty bad at writing consistently good tests. And this burns a ton of time. Think about that. Like, the test failed. How many times do you have the conversation, oh, I know that's a flaky test. Don't worry about it. We'll just run it again. Or even better, we'll just push to production because we don't have time to run the test suite again. And I know that's flaky, so don't worry about it, right? Okay, so that's one option. The other is software complexity. If your software is so complex that two people merging means all bets are off in terms of whether or not you're actually going to get a good result, then you should probably spend some time on that, right? This is how I feel about red builds. Red builds are terrible. They're terrible. And so we want to avoid them. So as we sat down and thought through this, that was the first thing that really came to mind, was master branch stability. Like, how good are we at keeping the master branch in a good, stable state, right? Number one. And with that, we talk about red builds and just the frustration of red builds and slowing people down and no one else can move. We also realize that there's time spent there. So if you're a good organization and your builds go red, everybody stops what they're doing, they figure it out, they get it green, and you move on. Some organizations maybe are like, I don't know, that seems frustrating. Let's go home for the weekend and we'll take a look at it on Monday. And no one can get anything done over that period, right? And then we start to look at other things. And this is about a year ago, we were thinking through just, again, what can we do without diving into our data? And we looked at, just through some conversations with folks, deploy frequency, like just how fast are you getting things out? And deploy time, how long does it take you to get something out into production? At the same time, or kind of around the same time in terms of research, but published more recently, Nicole Forsgren, Jez Humble, and Gene Kim put out this book, Accelerate. It's based on their DevOps reports, which you maybe haven't had a chance to read. And they came to some pretty similar conclusions. If you look at how they did their research, it involved a lot of surveys. And it's got a lot of scientific depth to it, which is super awesome. And I'm glad that they're doing this work. But we looked at that and said, well, what if we could actually just pull that out of our data? And then we could correlate against all the other things, all the other patterns that we see people doing, versus having to go back and sort of do more surveying and digging into these organizations. So we came up with a formula. And now, I will tell you, this is us scratching the surface. We're still figuring this out. But we tried to look at these factors that we've seen and figure out, okay, what really matters? And again, going back to what we see every day as builds flow through our system, and what we recognize as key factors in understanding your ability to get things done and deliver value, we sort of sat down and came up with this formula. And there's a second key point with that, which is we could have built a neural network or some other ML thing that I totally don't understand and would just farm out to, you know, Google's AI platform or whatever. But then what do you get out of that? You get back a number. And you don't know what to do with it. You have no idea how it was derived. You have no idea what the key factors are. Whereas I think when we talk about builds, people really inherently understand that. So this is the approach we took. I'm going to walk through a little bit of math. It's not super complicated. That was one of our goals. But basically, if you look at the numerator, you start out at a top line of 1, and then effectively get penalized for having a bad ratio of red builds to green builds. And at the point that your red builds outnumber your green builds, you head into the negatives. So we basically, I didn't put the limits on here. We cap at -1, because beyond -1, it's not really that interesting to worry about. But we basically have this range of -1 to 1 as a simple score to say, this is a project that's working effectively. And then in the denominator, we want to reduce the magnitude of the direction. So again, thinking about the time that's been spent, if you do have red builds, but you can get them resolved quickly, and you generally keep your stuff in a green state, that's a sign that you're moving effectively, because you're not blocking everybody else in the team. It's a little bit weird that it reduces the magnitude on the negative, but honestly, once you're in the negatives, once you have more red builds than green builds on your master branch, the magnitude probably doesn't super matter. You should definitely put some work into cleaning that up. Okay, so we came up with this hypothesis of maybe this is an interesting thing and will tell us something about some projects. What happens if we go look at our data and try to refine it? So we had 3 questions. What fits? What looks intuitive and makes sense to us? What doesn't? What kind of stands out? And what else can we learn? Oops. So number 1, again, I didn't say this before. I'm not going to claim causation. But if you look at this distribution, which is basically total builds, and this is all over the period of 1 month, which was August of this year, by project, and look at the NVS distribution, what you don't see is projects that we would consider to be negative, projects that are not good, moving a lot of builds. It's difficult to be effective and deliver at a high rate if you have lots of red builds. Again, everybody's stopping what they're doing and focusing on fixing things. Maybe they're just sitting there bleary-eyed at 3 o'clock in the morning hitting rebuild, 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 hoping to get past those flaky tests instead of getting something new done. So that's interesting. Makes sense. We sort of say, okay, that validates sort of what we're thinking about here. And then we took a different look, which is what if we tried to think about units of value in some other way? And if you follow a Git flow, you probably have topic branches. And if you have topic branches, they're probably related to topics, like this unit of functionality that I'm trying to deliver, this bug that I'm trying to fix. And so if we're churning through a lot of branches, then that's a sign that we're moving the needle. It's a theory, but it lines up as well, which is you don't see in the bottom right here people moving a lot of value and doing it in a way where their build is very unstable and inconsistent. Okay, so what can we learn? What about team size? I love this story that like 2-pizza team is the perfect team. But what is that founded on? How easy it is to order 2 pizzas? I'm not 100% sure. So what we see in this is team sizes based on active developers, people committing to the code base across projects in our on our platform, and the distribution. So there are teams well beyond 25, first of all, but it gets pretty weird out there. Having 200 people working on a repo, I think, is kind of an outlier and probably not something that you want to spend a lot of attention on unless you're Google or Facebook, and then it's thousands. For those not familiar with box plots, the little green lines in the middle of the box are the median, and the box spans the sort of top of the first to top of the third quartile. And then the whiskers are a prediction of the full scope. What I took off of this chart to make it easier to read was the outliers. And if you look at team sizes 1 through 5, you basically span all the way to -1 and all the way to 1. What's interesting about that, I mean, if you have a team size of 1 working on a project, it's probably not really important, right? It's someone's little side project. They're just maintaining this thing to do their notes, whatever. Although it's interesting to me that people would put their notes in CI. And then there's kind of a point in the middle there around 7, 8, 9, 2 pizzas, where the variability gets much smaller, right? And so the median is kind of consistent, but the likelihood that you're going to be way out of that range gets a lot smaller. And then once you cross past that, it gets all over the place. I mean, look at 20 to 25. It's super squirrely. Nobody knows what that's going to look like, right? And that does line up with our intuitive sense. So organizational culture, this is a really interesting one to me. This is 12 organizations who are at the large or the high end of number of projects on our platform. They're not actually named 0.301, but this is all anonymized data. So the number that's in there as the name of the plot is their weighted or aggregate NVS across the organization. And these are histograms from -1 to 1 based on projects. So if you look at the top left, and in fact, if you look everywhere, everybody has a crappy project. Everybody has a project that maybe they just don't care about it. But again, why are they running CI and CD on a project that's not important? That's an interesting question. But if you look to the bottom right, where you have a high NVS overall, you've got an organization that skews all of their work towards paying a lot of attention to the quality of their builds. And if you look to the top left, you've got an organization that still has some good stuff. I mean, everybody has stuff up at the top end as well, but they don't care as much about all of their projects. So there's some interesting digging to do here. Is it about teams, individual teams? Is it about specific projects in the organization? Not 100% clear, but this gives us something to go talk to people about. And why would you ever have a conversation about code quality without fighting about languages? That would be crazy. So I love this chart because we're a closure shop, and I 100% swear I did not fix this chart. I did not take the closure number and just move it up to the top. But there are a couple of intuitively interesting things in here, like the dynamic languages being kind of clustered together, right? The way that people write Python and Ruby, I don't know about Shell. We'll just assume there's no tests on those. Those kind of cluster together in JavaScript, right? And then as you get down below, you kind of move into typed languages. Does that tell us something specific? I doubt it. I'm not going to stand up here on stage and tell you to stop using typed languages and move to Clojure. I'm just not. But this is interesting stuff to think about. And then at the very bottom, you've got Objective-C, C++, and Swift. I mean, Swift, I don't know what to say about that, but mobile development is sort of notoriously hard, right? Like, it's hard to test it effectively. You could see scenarios where the code is complex, and getting a good, stable build process would be hard. So it lines up. It kind of makes sense, and it's interesting to think about. OK, so let's go talk to some customers and find out what they say, right? And the thing that we kept hearing when we talked to customers was, oh, yeah, that's because. So let's talk about this customer. This is the first chart that I showed, which is just total builds against MVS. And we know this customer. And we went and talked to them. And we said, hey, do you know you have this build? It's actually moving pretty rapidly, this project. A lot of work is getting done, but it's like constantly broken. What are you doing? And they said, oh, yeah, that's because we have this linter that basically never works. OK. So what we do is we ignore that job in the workflow. So this is a workflow. And they just have a job to nowhere that they expect to fail, and they ignore it. But the result of the workflow is red. And the way they determine whether they should actually keep going is they go and look at the output, check all the jobs, and make sure that the job they expect to fail failed. That's the only reason that it's failing. Not super productive. I mean, there's a reason that we post your status back to GitHub, so you can just look at it and go, OK, I'm good. Not so you can click through and go read the output and say, oh, OK, yeah, the thing that I expected to fail failed. Everything else is fine. Let's ship to production. You'll be unsurprised to learn that this customer is basically exactly the same. This is a super high volume customer doing tons of work, massive team, and slightly different scenario, but they have a job that requires on a third party, or that requires or depends on a third party service, and their free trial ran out. So they just kept building, and they just ignore it. And every time the workflow fails, they go and look at the workflow, and they go, yeah, the thing with the free trial, that's the thing that failed. Everything else is fine. We can ship now. I mean, this is why you have this data. If I had this data and I was an engineer, I'd go to my boss and say, look, this is a problem. We are not able to get more work done because you won't pay for this $99 a month trial or thing that the trial has expired. And have the conversation. At least either it's useless, so let's take it out of our build, or it's worth $99. Let's spend $99. Like, if you have 200 plus builds a month, you have a lot of engineers on your team. And all of those engineers are spending their time looking at whether or not the free trial is the only thing that failed in your workflow. OK, so what does this all do for you? What is the opportunity here for all of us? The opportunity of owning our own story. So I think notoriously, as engineers, we are reluctant to be measured. Every time someone shows up with some measurements, our response is, you're measuring me. I don't want that, right? I don't want to be graded on my ability to move 3 story points versus 4 story points across the board this week. This is about me, and I feel uncomfortable. But as a result, we create this void, right? We create the void in the story, and the void gets filled in. Trust me. I can tell you, as a CTO, as a manager when I was a manager, as an engineer, as a human in society, the void gets filled in. So you want to do the filling. That feeling of flight. This is what you want. You want to be released, right? You want to remove all the weight that's on you and be able to focus on things that matter. But let's be honest, this is a canary metric. Sorry if this is disturbing. We talk about canaries all the time, and it occurred to me that actually they were canaries, like real canaries. That's kind of freaky, but don't worry, they stopped. Now they have little digital meters to check the carbon monoxide level. But it's a canary metric, right? It's not going to tell you this is the thing that's wrong in your process, but it is going to tell you your project relative to everybody else's projects is not that good. Maybe you should invest some time so that you can move a little more effectively as a team. So let's say this is you. And this is your feeling about the flaky tests in your environment, right? Every day, oh my God, here's the flaky test again. Sure, everybody go to lunch. I'll just keep hitting the retry button. Maybe by the time you get back, we'll have a green build and we'll be able to put this thing in production. Don't live like that, right? Prove to the people that you work with, the people that you work for, that this is not how everyone works. Let's share and open the conversation and be able to say, hey, I need to get some time to fix these crazy flaky tests. I mean, I, as a CTO, now fix flaky tests because I'm like, this is crazy. What are we doing? Yeah, you're welcome. Maybe your CTO doesn't, I'm not sure. But get that focus, right? Get that energy. And then for your team, right? Again, coming to your manager, to your VP of engineering, CTO, whatever your organization looks like, I don't know. Winning is awesome. Winning is super fun. And we all want the same thing. And I think this is, again, coming back to being reluctant to take on numbers, et cetera. This is a thing that we struggle with, is recognizing that the engineer who's managing me, the engineer who's now the VP of engineering, whatever, we all want the same thing. We want to win, and we want to enable our teams to win. And looking at data and understanding the quality of the work we're doing and how effective we're able to be gives us the opportunity to win. So what should you take away from this? Number one, invest in your effectiveness. If you're not, it's slowing you down. And somebody else out there who's working on the same business as you is investing in their effectiveness. And they're making faster progress against the things that really matter. They're delivering value, and they're going to win. Number two, own your story. The story is getting filled in. People are looking at what's happening, and if they don't have the information that you have, they're going to make their own decisions, their own ideas about what's happening, and it's probably going to drive you nuts. And then number three, share. The more we can talk about the things that really aren't secret or different about us as engineering teams, the more we can all focus on the things we really want to focus on, which are the interesting problems, delivering value, and shipping at 4 p.m. instead of 4 a.m. So here it is again, for anyone who didn't manage to take notes or take a picture. If you want to try this out, run it on your own stuff, of course, I could probably tell you, depending on what your organization is. Let's talk about it. I mean, I'm interested in hearing from you. If you are interested in this, if you want to know what this means for you, if you have ideas about the kinds of work that you don't get to do, that you could focus on if they were supported with data, I would love to hear about them because we're very interested, again, as an organization, not just as software developers, but people sitting in the development pipeline to think about what it's going to take to make everybody around us more effective so we can all focus on the things that really matter to us. So own your story and be happy. Thank you.